Morning everyone. Today we're going to start 9.3, finding special products of polynomials. So the first thing I have here is 4x minus y squared. So what this is telling us is that if we had maybe let's say 7 squared, what that's telling us is we have 7 times 7. Here we have 4x minus y squared. So what that's telling us is that we are going to multiply 4x minus y twice. So 4x minus y times 4x minus y. So we have two binomials. So what we can do, how we work this out by solving it, is we can draw a box with 4 squares inside of it. On the one side, we're going to have 4x minus y. On the other, we're also going to have 4x minus y. So we just need to multiply these. So 4x times 4x gives us 16x squared. 4x times negative y, negative 4xy. 4x, or negative y times 4x, again, negative 4xy. And negative y times negative y gives us a positive y squared. So if we wrote this out then, we would have 16x squared. Now I see two things here that have the same ending. So what I'm going to do is I'm going to combine those two things. Negative 4 minus negative 4 gives us negative 8xy plus y squared. Same thing over here. We're going to draw our box. This is telling us that we have two 3x plus 4s. So 3x plus 4 and 3x plus 4. 3x times 3x, well, 3 times 3 is 9. X times x is x squared. 3x times 4, that's 12x. 3x times 4 again, 12x. And 4 times 4 is going to give us a positive 16. So what I see is I have two 12x's. So I'm going to combine those. So we're going to get 9x squared. 12x plus 12x is going to give me 24x. And then we finally have plus 16. Alright, if we take a look at these, we have 3m plus n to the second power. So what we're going to have then, is if we draw our box, we'll have 3m plus n and 3m plus n. 3 times 3 is 9. M times m is m squared. 3 times 1n is 3. M times n gives us mn. 3 times 1 again is 3. M times n is mn. And 1 times 1n gives me positive n squared. So I can combine the three mn's and get 9m squared plus 6mn plus n squared. Alright, I want you guys to try this next one on your own. Remember to draw your box out if that helps you write it out so you can see exactly what you're doing. Alright, now we have two binomials again. This time they're going to be different. So they're not going to be squared anymore. So what we're going to have then, we're going to have x minus 3y and x plus 3y. Well, x times x, that's going to give me x squared. X times 3y is going to be 3xy. Negative 3y times x. This time it's going to be negative 3xy. And negative 3 times 3 gives me 9. Y times y gives me y squared. Now what happens here is I have negative 3xy and 3xy. Those are going to cancel out. So what we're left with is x squared minus 9y squared. Over here, we have 2x plus 1 and 2x minus 1. 2x plus 1, 2x minus 1. 2 times 2 is 4. X times x is x squared. 2x times negative 1, negative 2x. 2x times 1, positive 2x. And 1 times negative 1 is negative 1. Now, negative 2x and 2x, those are going to cancel out. We're going to get 0 out of that. So what we're left with then is 4x squared minus 1. Alright, I want you guys to try these two on your own. Once you're done with that, you can go on to slide 5. Alright, we're going to talk about Punnett squares now. Now, you guys may have seen these in science. You may have seen them in 7th grade science when you guys were doing genetics. So, we're going to start talking about these with multiplying our letters. So it says the color of the dark patches of a border collie's coat is determined by the combination of two genes. An offspring inherits one patch color gene from each parent. Each parent has two color genes, and the offspring have an equal chance of inheriting either one. What percentage of the possible gene combinations of the offspring result in red patches? So, looks like we got B and we got R. I'm going to say B is brown and R is red. So B is brown, R is red. So if we have a parent, they're both BR. So B, big B, little r, big B, little r. Two big B's is going to give us B and B. B times R is going to give us B and R. R times B is going to give us B and R again. And then R times R is going to give us R and R. So it looks like R is the small, which means that R is our recessive. So we would have to have both little r's to get a red patch. So what percent of the possible gene combinations result in red patches? Well, it looks like we have 1 out of 4, so about 25% chance. So if we show how we can use a polynomial to model the possible gene combinations, well, a polynomial that we could have is two B's, two big B's. The B and the R, both of them have 2 of them. So we could have B, big B, B squared, R squared, plus little r, little r. Alright, so this one says perform the indicated operation using the functions f of x equals 3x plus 0.05 and g of x 3x minus 0.05. This one says f of x squared. So we're going to have 3x plus 0.5 times 3x plus 0.5. So this is squared. We're going to have two of the same. So if we draw our box then, 3x 0.5, 3x 0.5. 3 times 3 is 9. X times x is x squared. 3x times 0.5, well, what's half of 3? That's 1.5x. 0.5 times 3 again is 1.5x. And then 0.5 times 0.5 gives me 0.25. So here I can add 1.5x and 1.5x. So we get 9x squared plus 3x plus 0.25. This one is saying f of x times g of x. So f of x is 3x plus 5 times g of x, and g of x is 3x minus 0.5. So if we drew our box here, we'll have 3x 5 plus 5, 3x minus 0.5. Oh, this is 0.5. I made a mistake there. So plus 0.5. 3x times 3x gives me 9x squared. 3x times negative 0.5 is a negative 1.5x. This one is a positive 1.5x, and then a negative 0.25. So if we combine these two, 1.5 minus 1.5, those cancel out. So we get 9x squared minus 0.25. Lastly, g of x times g of x. So what we're going to have is those times the same thing. So 3x negative 0.5, 3x negative 0.5. 3x times 3x, again, is 9x squared. Negative 1.5x. Negative 1.5x. And now a positive 0.25. So we get 9x squared minus 3x plus 0.25.